Unit 3B, Lesson 2. In this lesson, we're going to focus on restricting the domain for a function when given certain situations, as well as calculating the average rate of change over the course of an interval for a given function. First, we need to review the real number system, and we're going to focus on the subgroup of the rational numbers. The rational numbers have many different subgroups. First, we have the natural numbers, which we often refer to as the counting numbers, 1, 2, 3, 4, 5, and so on. The whole numbers include all of the natural numbers, but we add 0 to it. So it's 0, 1, 2, 3, 4, 5, so on. Integers include positive and negative whole numbers. And then, of course, we have the rational numbers, which includes all of those integers, fractions, decimals. So you need to recognize these different subgroups. We're going to use these when trying to come up with domains for certain functions. We also need to discuss the difference between discrete and continuous. Discrete variables can only take on certain values throughout an interval. For example, the number of sales made in a week, the volume of milk bought at a store. A continuous variable could take on any value within that given interval. For instance, the depth at which a drilling team strikes oil, or the volume of milk produced by a cow. Now we're going to go through a few examples determining which set of data is most appropriate for the domain for the given function. The first one, officials in a town use a function C to analyze traffic patterns. C of n represents the rate of traffic through an intersection where n is the number of observed vehicles in a specified time interval. What would be the most appropriate domain for the function? For part A, we have the set of integers. These ellipses mean we're going to get more negatives, so -3, -4, the same way in the other direction, 4, 5, so on. Part B is a set of integers only going from -2 to 3. For part C, it starts at 0 and goes by intervals of 1/2 and stops at 2.5. And then interval D starting at 0 and continuing on 4, 5, 6, so on. So we're trying to determine which one is most appropriate to represent the domain. The domain in this case is the number of vehicles observed within a specified time interval. So if we're counting the number of vehicles, that has to be a whole number. We can't have part of a car, and we can't have negative amounts of vehicles passing through. So we can eliminate parts A and B because we can't have negative values. We can eliminate C because we can't have part of a vehicle. So the only answer choice that would make sense in this case would be answer choice D. 0, 1, 2, 3, so on and so forth, counting the number of vehicles. So that represents the whole numbers because we have the natural counting numbers 1, 2, 3, 4, and we can include 0. Now in the second problem, we have a construction company uses the function f of p, where p is the number of people working on a project, to model the amount of money it spends to complete a project. A reasonable domain for this function would be part A, we have positive integers, B, positive real numbers, C, both positive and negative integers, or D, both positive and negative real numbers. This is going to be very similar to the last problem because our domain, our input in this case, is represented or refers to the number of people working on a project. You can't have a negative amount of people, so we can eliminate choices C and D right away. And we can't have a part of a person working on a project, so we could eliminate answer choice B. The only choice that makes sense in this case is choice A, positive integers, because we're referring to the number of people. The last part of this lesson is going to include finding the average rate of change for a function over an interval. In this case, we have h equals -16t squared plus 144 over the interval from 0 to 3. H represents the height of some object, and t represents the time after we've let it go. This equation represents an object in free fall. Okay, so what we need to do is find the ordered pairs represented by these endpoints. So we're going to plug 0 into this equation to find the corresponding h value, and then we're going to plug 3 in for t in our equation, simplify it to find the h value, so we have these two ordered pairs. So the first ordered pair, if I plug in 0 for t, I'm going to be left with 144. So my initial point is 0, 144. Now if I plug in the second point, which would be a t value of 3, 3 squared is 9. 9 times negative 16 is negative 144. Negative 144 plus 144 gets me 0. So we have our two endpoints. If we're looking for the average rate of change, all we have to do now is find the slope between these two endpoints, y2 minus y1 over x2 minus x1. So plugging these values in, we would have 144 minus 0 over 0 minus 3, which will simplify to 144 divided by negative 3. Then if we take 144 divided by negative 3, you get negative 48. So that's the process of how to find the average rate of change for a function over a given interval. So in this lesson, we reviewed the different subgroups for the real numbers when talking about domains for certain functions based on the situation. We talked about discrete versus continuous, and then we finished by going through how to find the average rate of change for a function over the course of a given interval.